Assalamualaikum, my name is Amir Hazmi bin Mohammad Hanapiah and my metric number is B0922011179. Today I will explain about the introduction of a machine condition monitoring and a fault diagnosis for gear. Machine condition monitoring involve a real-time tracking of gear, help through the use of a sensor that measure various parameters such as a vibration, a temperature and a pressure. This continuous monitoring help detect early sign of issue like gear misalignment, wear, crack and lubricant degradation before they evolve into a serious failure. Fault diagnosis that analyze the collected data to pinpoint the exact types and location of the fault, often employing advanced algorithm and signal processing technique. Vibration analyze, a common diagnostic method reveal imbalance, misalignment or gear tooth damage by detecting change in a frequent amplitude. By identifying a potential issue earlier, machine condition monitoring enable a predictive maintenance, allowing repair to be performed only when necessary. This approach not only prevent unexpected breakdown but also help avoid unnecessary downtime and excessive inspection, ultimately enhancing the efficiency and lifespan of the machinery.
Assalamualaikum, my name is Mohammad bin SAMSUDIN and my metric number is B0922100142. So I will continue the presentation about definition. Machine condition monitoring and fault diagnosis gear involve observing gear system in machine to ensure they operate properly and to detect early warning sign of failure. This process focuses on identifying issues before they lead to breakdown. By monitoring the gear condition and diagnosis for early, maintenance can be planned effectively to avoid unexpected machine downtime. So I will give you example for common gear fault, which is the first one is wear, second one is crack, pitting or tooth breakage, and then I will explain about technique to use. To prevent sudden breakdown and cause downtime, condition monitoring techniques such as vibration analysis, acoustic emission, oil debris analysis, and temperature monitoring are applied. This method collects real-time data, which is then analyzed to identifying pattern or indicator of fault. By using this technique, industry can shift from reactive fix after failure to predictive maintenance strategy, resulting in increased reliability, improved safety, lower maintenance cost, and extend equipment lifespan.
Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Mohammad QUSYAIRI bin ROSLI and my matrix number is B0922100117 and I will continue the presentation for our assignment, which is machining condition monitoring and fault diagnosis for gear. So why is it important? Because it to meet the goal of RMR. RMR stands for reliability, maintainability, and risk. Condition monitoring provides opportunities to detect fault routinely and before they cause failure such as damaged gear teeth, misalignment, crack failure, or any lubrication failure. Next, it is important to implement preventive maintenance, or we call it PM. Condition monitoring and fault diagnosis are proactive maintenance and approach that incur less cost and minimize downtime to assure ongoing effectiveness. When we implement preventive maintenance, we can reduce the cost and the downtime of a certain production and reduce the risk of the workers. Next is improve performance and extend machine life. Condition monitoring systems are equipped with sensor technology that, along with data analytics, give real-time knowledge of the actual operating condition of gear, enabling predictive maintenance approach. So instead of preventive, we also have predictive maintenance, which is condition-based maintenance, which is detect real-time condition of a certain component, and If there is expected failure, we will change it to meet our goal of RMR. Next, I will talk about how to measure. So the first one is vibration analysis, where the sensor, mostly accelerometer, are mounted to the gearbox. The gearbox is for an example to measure the vibration pattern. The vibration pattern are further analyzed with methods such as fast Fourier transform that can be used to measure the frequency of the gear fault. Each of gear fault it has a different pattern which lead to different fault that we can consider and detect when there is a pattern that emerges in the system. The second is acoustic emission. This is involved in measuring the high frequency stress wave produced when a crack first start or when a tooth gear break. Acoustic emission monitoring is very sensitive to low frequency wave and could in fact detect a part of component before it's become a problem. And the last one is ultrasonic testing. Ultrasound monitoring can detect high frequency signal caused by friction or impact. This testing method is often used to evaluate the condition of lubricant and can help determine early wear. Ultrasonic testing is a very common non-destructive testing that is widely used to many industry. So it is also reliable to measure and to use in condition-based monitoring and gear to detect before the failure occur and it can before it became catastrophic that we have to do proactive maintenance and or we have to replace the whole part. So that's all from me. So thank you.
Hello, my name is WYNER William, matrix number B0922210042, and now I'll wrap things up by concluding for this topic. So, in conclusion, vibration monitoring techniques and fault diagnosis methods, particularly for gear systems, are important as it helps to extend the machinery's lifespan, to reduce the maintenance costs, and also to increase the operational safety. So it also helps the industry in transition from reactive maintenance to predictive maintenance, where it can enable the early detection of faults. So in final words, vibration monitoring and fault diagnosis improves the overall performance and reliability of the system, while also ensuring the compliance of safety as well as quality standards. Thank you.